Hi everyone, this is Jo from chembiojo. Today we're looking at using the periodic table and being able to understand the different parts of the periodic table. What do the numbers mean? How is it going to help me in an exam, in a calculation, in answering questions? The periodic table is really useful to be able to understand and interpret correctly because it helps us in so many areas of chemistry. Like it helps us look at the different patterns down the groups in a periodic table. If you're doing A level, it helps us to look at the patterns in the periods across the table, so the periodicity that you'd study in A level. And then also things like position in the periodic table. Are we talking about a metal? Are we talking about a non-metal? And then also maybe the type of bonding that might be part of. So it's really important that we can use the periodic table to our advantage. A lot of you will be familiar with this periodic table. It's from the AQA paper, so you'll see this in an exam paper. And you'll find that with this type of periodic table, they do have a key. So the key is telling you what does the different individual boxes, what are they showing you? So you can see from the key, you are being told what the numbers are. So you've got relative atomic mass at the top, and then the atomic symbol. So each element has its own symbol. You'll have the name in small letters, and then the bottom number is the atomic number, which is also known as the proton number. So that's really, really helpful. But I think it's important that you can look at the periodic table and not need to rely on a key and be able to quickly process the information that's shown to you. You'll also notice that sometimes periodic tables, although they look similar, they might just be slightly differently arranged, and that's because the numbers can be the other way around. So you can have relative atomic mass at the bottom and the atomic number at the top. So it's important to recognise which number is which, and we'll talk about that in a little bit later. So before we start analysing those numbers and looking at a specific example, we need to remind ourselves of the subatomic particles, which are our protons, neutrons and electrons. I've included a graphic at the bottom of the slide here to show you, just to remind you that protons and neutrons we find in the nucleus of the atom in the centre, and then our electrons are whizzing around in shells around that nucleus. The important thing that we're looking at today then is their relative charge and relative mass. Relative as in relative to one another. They are not measured in any kind of units, but we describe them as having relative charges to each other and then relative masses to each other. The charges are important, and we'll talk about why later, but think about things that help you to remember key points. So for example, proton begins with P, positive, +1. So the relative charge on the proton is +1. A neutron sounds a bit like neutral. So a neutron has a 0 charge, doesn't have any charge. And then the electron, our third one, is our -1 charge. So those relative charges are really important, and they'll come up obviously when we look at things like ionic bonding, but they also are really important for the atomic structure in general, and the idea that overall an element is neutral. Overall an element has no charge. So that's telling us something about how many protons and electrons we need. We need to make sure those charges are balanced out. Relative mass. So again, this is the idea that relative to each other, the proton and neutron have the same mass, and we just give them the mass of 1, again with no units. Then if we have the electron, comparing them to the proton and neutron, an electron's really small. So sometimes you might see that written in words, as in an electron's mass is very small. It might say close to 0. It might also be given numerically, so you could describe it as having a mass of 1/1836, which is the same as saying it has a mass as 0.0005. The thing we would never say is that an electron has a mass of 0. Because then if it had a mass of 0, technically it doesn't exist. So we need to make sure that we're careful around the language that we use. It's up to you what you prefer. Some people prefer to write down the numerical value, and other people prefer to say it's really small or it's close to 0. Let's take this example of boron then. So boron from the periodic table has symbol B, and the numbers that we see on boron in the style of the periodic table I've just shown you is 11 at the top and 5 at the bottom. So the numbers then, what do they mean? Our 11 is a relative atomic mass, and relative atomic mass sometimes has the symbol A with a subscript R. And that's just a shorthand way of writing it down. And your relative atomic mass, if you think about it, going back to what we said before, the things that have the most significant mass are the protons and the neutrons. So this number is equal to protons plus neutrons. And the way I like to think about it is that if you're using a periodic table that's a little bit unfamiliar to you, and you've got to choose between the numbers, which one's relative atomic mass, go for the bigger number. So your bigger number that you'll see will always be the relative atomic mass. The 5 is our atomic number, which is also known as proton number. So there's a really nice clue in the title there. If it's the proton number, then it's telling you how many protons there are. But what we said before that's really important, overall boron doesn't have a charge, it's neutral. And so we need to think, well, if there are 5 protons in boron, that means there are 5 positive charges. In order to balance that out, we need 5 negative charges. So therefore we need 5 electrons. So your atomic number or your proton number tells you how many protons there are, which is equal to how many electrons there are. That makes sense when we go back to our table, because we said before then that relative mass, the only things that have really significant mass are your protons and neutrons. So that's going to be taken into account in our relative atomic mass, the number 11 on boron. And then in terms of charge, we know that we need to have a balance of positive charges and negative charges. So we're going to have the same number of protons as electrons. So if we were asked to say what are the number of protons, neutrons and electrons in boron, we've got information from the periodic table that we can use, and we'll be talking about this. So the number of protons is 5, the number of neutrons is 6. So if we think about how we'd work that out, we'd say, okay, well, 11 minus 5 gives us 6. And then the number of electrons is always going to be the same as the number of protons, so we've got 5 electrons. Let's have a look at a periodic table of elements that looks slightly different to the AQA version that I showed you before. I absolutely love this one. This is from PubChem. The reason why I love it is because you can view the periodic table by displaying lots of different types of trends. At the moment, this is automatically set to display atomic mass. But if you look at this drop-down menu, you can change it to so many different types of properties. This is super helpful for when you're doing A-level and especially for periodicity. So I'll leave it set as atomic mass. And you'll notice that it does look a bit different to our AQA version, because this time, let's have a look at boron. The 5 is now at the top, and the 10.81 in this instance, so it's a more accurate mass, is at the bottom. You'll find that on some periodic tables they will round up the numbers. So say in our last example we had a relative atomic mass of 11. This time it's 10.81. It's to 2 decimal places, so it's just a slightly more accurate number. That's going to be really helpful for when you start to do calculations in chemistry. It's really good to use more accurate numbers, or more accurate numbers where you can. It doesn't mean that it's telling us any different information though. Boron still has 5 protons, it still has 5 electrons, and it still has 6 neutrons. So that doesn't change. But the numbers that they're using are just slightly more accurate. You'll notice that there is also a key here as well. So if you're ever not sure, check for the key. It tells you that it's atomic number at the top. You've got the symbol, the name, and then the atomic mass is the number at the bottom. Thanks for watching today, and let me know in the comments if there's anything that you'd like to know about the periodic table to help you with your studies.